Hello, everyone, and welcome back to another exciting semester of stats. We are starting off strong with looking at MANOVA. Now, MANOVA is very similar to ANOVA, except we're adding another layer of complexity to it, essentially. Um, so, yeah, it's essentially the same thing, but we're just dividing up that difference a bit further now. And so with that, we can look at even more variables. So um, as you can read here, our data set for this week is SET data, where we're looking at the ratings for the instructor, the course, and the enthusiasm the student has. So as always, before we can actually get into doing the MANOVA, we're going to look at the assumptions for MANOVA. Sorry, not ANOVA, MANOVA. And the assumptions are basically the same as for an ANOVA. If you mashed it together with a regression, essentially. So as always, we want to look for outliers, both for the independent variable and the dependent variables. We want to look at univariate normality, but we also now want to look at multivariate normality. And that's because there's multiple dependent variables, and so, as always, things get more complex. Linearity, so is the relationship between things linear? Because if it isn't, these stats won't work. It's based on linear relationships. Is there that homogeneity in the variance-covariance matrices? We don't want multicollinearity or singularity. We want independence of observations, as always. So why don't we start out by looking at how to get these. Now, in today's lab, we'll be going over, in this lab video, we'll be going over how to get this output and maybe some of the preliminary interpretation. And then in lab on Monday, which will be at 9, we will start actually interpreting this, seeing if these assumptions are met and what to do about them if not, and actually running the MANOVA. So with that, here we go. So first off, you want to do a visual inspection. Do you need to? No, and it doesn't tell you everything, but it's very useful. So there's a number of ways that you can get this, but I like descriptives explore. Now here, the dependent, sorry, let me just double check, and dependent I think these are dependent and factor is independent. It's hard to remember before we start doing this, but yes, this seems right because we have multiple DVs. So this is how you'd want to do it. These are your dependents. Enthusiasm is your independent. We're putting enthusiasm on its own thing because remember, when we are looking, when we divide up a group by into smaller categories, we need to make sure that there's normality within each category, not just overall. So here, I want plots. You could get yeah, box plot is nice. Stem and leaf is gross. Histogram is nice, and might as well get the normality plots, though I think we'll get them again later. Normally I would paste, but just for right now, let's click OK. My computer is being slow, but I'm not going to edit this out for you, I'm sorry. Okay, so here's what we got. So our sample is divided into 3 sections: low enthusiasm, average, and high. And so we have the dependent variables, instructor scores, and course scores divided that way as well. Now we have these descriptives, which we can look at the same way as we've looked at descriptives for multiple others. So we can look at the skew here, we can look at the kurtosis here. Just off the bat, this probably is large. This looks like it's probably going to be a bit skewed and a bit kurtotic. Don't know which direction. So something to think of, but we are here for the visual inspection. So, and again, test of normality, which we'll actually get a bit later, but that's how you get it anyways. So here are the actual histograms. Looking at this, I can see why it was showed as slightly skewed. These points over here are likely what's skewing it the most. They're probably a problem, would be my guess. This one, fairly good, but again, some outliers over here down on the bottom. This one looks pretty normal, a bit more skewed, and wouldn't be as fixed by getting rid of this one outlier, but there is still an outlier. Then if we look at these QQ plots, so my personal preference is I don't like looking at the normal QQ plots. I like looking at the detrended because I think it's easier. And again, we can see those initial 2 outliers that the histogram suggested. You can see this one, there isn't quite as clear outliers, but there is kind of these ones that, you know, are getting quite away from the line at this point. And here again, things are pretty good, except this one especially. So looking at these, I'd say we definitely have at least 3 outliers, would be my guess, maybe more. Now if we look at the box plots, anything, so I think I've already talked about this, but anything not within the whiskers, it's saying is an outlier. So here it's telling us there's actually 3 outliers, here a bunch, but this one especially, and a bunch here. So these are all things that are being marked as potential outliers. So that was just looking at based on the instructor score, based on the overall course score. This looks like a bit of an outlier. This might be, but it's less likely to be because it's nice and close to the mean still. This looks not bad, but it levels out quite a bit here, so I wouldn't be surprised if some of these were outliers. And again with that, so it looks like everything here is a bit negatively skewed, with the outliers in the negative direction. Again, I like looking at the detrended. Here we see this one that's quite far away, so if we just look at what the values are here, this is between -1 and 1.5. I don't really have values to tell you for this, but over 1 is definitely a lot. Again, that's quite far. These ones are also quite far. So it looks like we're going to have quite a number of outliers, and that's also what it's saying here. So that's the visual inspection. Pretty typical, but we can't really just go and delete all of these things based on that. I mean, this is a huge data set, so we could, but we're not going to. We're going to use actual stats. Next up is the statistical inspection. Now, you'll notice that how we actually get these outliers is very similar to what you've already done. For these univariate outliers, all we're doing is looking at how the standardized value. So is it plus or minus 2.5 or 3 or whatever cutoff you want, z-scores away from the mean? Is that an outlier? So similar to what we have done for other things. And then if you're looking at multivariate outliers based on x, we get this by running a regression. And so essentially, we're doing the same outliers, same way of finding outliers as we learned last semester. All of this is the same. It's just for a new thing. And we're using a regression because just remember, everything is a regression. It's just like 3 regressions in a skin suit. Okay, so let's look at the univariate outliers first. So analyze, descriptives, just these two. Now I could get these, but I don't even want it because I already got it earlier. They make me, okay, you can have mean. You can have the mean. But mostly what I want is this. I really just want that. So if I click OK, again, you should click paste, but I'm not doing that right now. We get barely anything here because what we really wanted is these. So now I have z-scores. So if I sort ascending, you can see, wow, here we have all of these based on whatever our cutoff would be are over 3. How many? We have almost 1,000. So I would suggest in this case, right, if we used a cutoff of 1.96, well then we'd expect 5 cases in 100 to be outside of that. With 1,000 cases, we would expect 50 to be out of that. That's not really an outlier at that point, right? We could use 2.5, but then that's 1 in 100. Here, again, almost 1,000. So we'd expect there to be 10 of them. So again, still not much of a cutoff. So I'd use 3, or even find out what the next higher one is. I think 3 is probably fine, because then we only expect there to be 1 above a cutoff of 3, and so we can say that these are all outliers, especially this. This is quite out there. And now what I would do here, if I were you, is write down all of the participant numbers for these, because you're going to want to cross-reference later to see what do we want to delete or Windsorize or keep in, right? Whatever you're doing. So we sort ascending, we sort descending. Here, this looks fine, which fits with the negative skew that we saw. Here, we find another 8, which most are the same as before, but not all of them. And then these are fine. So that's how you'd look at outliers in a univariate way. Multivariate is different. Here, we are going to run a regression because we're just going to trick them into giving us what we want. What the dependent is does not matter. All right. Yeah, dependent doesn't matter, so I'm just going to put that in. And then both of these are going in as independent, and that's just so that it will give us the stats that we want. When we're looking at these outlier things, it does not matter what the dependent is. So now we want to go to statistics. Care about none of these. Again, you don't have to click off of all of this. We might want that later, but not right now. Save. Save is really what we want. And what of these do we want? Well, that's a great question, person that I'm pretending to talk to for this. It's based off of, again, exactly what we did last semester. So you could use any of these. I mean, I wouldn't suggest the unstandardized ones because they're not standardized. But whatever you think fits best for you. So in here, we're suggesting that you get the Mahalanobis and leverage. And so again, that's because they are for outliers on X, which is what we put into the equation, right? The outliers on Y wouldn't really mean anything because we put in a random Y. All we care about is this outliers. So I'm going to continue. And again, you should paste. I'm not. And all of this stuff, I care about it 0%. Because I'm not actually looking at a regression. I did that for these. Now, in terms of cutoffs, you'd want to, again, use the table to figure out what the cutoff is. Same as before, I'm not going to go through that with you. And then write down what participant IDs you have a problem with. Cross-reference. Now, if you want, you could make your decision on what to do with those problems now, or you could go on to the next step. I'd say, personally, I would probably go on to the next. No, I'd probably take them out before continuing to the test. At least take out the super egregious ones. Maybe check the rest of the assumptions with and without. But whatever you want to do, I'm, for the purpose of this lab, just going to continue on. There will probably be something different in lab. So now that we've looked at outliers, or you have rather, let's go on to testing the assumptions. So singularity / multicollinearity. Here, same way as we did before. I'm not going to pull this up. You just need correlations, right? You could also, if you want, run a Durbin-Watson, run another regression, get the Durbin-Watson, and have that tell you. Doesn't matter. And then here, there's it says visual inspection of normality, univariate normality, which is what we've already done, so I'm not going to go over it again. So getting those descriptive stats that I was looking at, the skew and kurtosis, so if I go back all the way to the top to my descriptives, looking at the skew and the kurtosis, and you divide the statistic by the standard error, then you get, a standardized score, and you can see if that's outside the realm of what would be considered normal or not. So that's how you do that. You'd also want to look at the histogram and the normality plots with tests, which is what we also did, though I skimmed over it. So looking at this, specific to what we're doing right now, something that you might want to look at is these means. So a mean of 5.5 for enthusiasm, a mean of 5.3, for overall course, mean of 5.5, 5.6, 5.7. This can be important sometimes depending on what scale you're using. So here we can see the scale goes to 7, right? It's probably 1 to 7. But we're only really using from 4 to 7. And that's an interesting part of developing a scale and trying to figure out the correct values. So here, this tells us people typically don't give bad ratings for their instructors. They don't typically give very bad ratings for the course. Generally, people say it's at least medium, if not good. Now, if we were seeing the mean be 6.7, like more around here, and this is the cutoff, that might also be something to worry about, because at that point you're reaching the ceiling, and whatever effect you want to find, you probably won't, because the scale doesn't expand to what you want to look at. So that's a tangent that if any of you have taken measurement and testing, you've probably heard before, but I think it's interesting. Okay, so this is to look at, this is for univariate normality, which is necessary but not sufficient for multivariate normality. So here we found already that there were some problems with univariate normality, depending on how we're looking at it, likely due to those outliers. So again, probably want to get rid of those egregious outliers before looking at this. Because if you have a problem with univariate normality, you will have a problem with multivariate normality. And looking at multivariate normality, you can kind of look at it, but it can get confusing, and the more variables you add in, the more confusing it is. So right now, with just 3 variables, it shouldn't be too bad, but it can get bad. So in order to look at multivariate normality, and we'll be looking at linearity at the same time, we are just going to do bivariate scatter plots for each dependent variable combination. So here we only have one dependent variable combination, right? We can only combine, we only have two dependent variables. So they can, sorry. This is our independent variable, and we have two dependent variables. This has three different categories, so you can't really do a scatter plot with it, right? That would just be better as a histogram at that point. But these are continuous, as the dependent variable should be. And so what we're doing here is we're going to do a scatter plot comparing the two. Now, if we had three dependent variables, that's when it gets really fun. And instead of just doing one to compare two, you'd have one with 1 and 2, sorry, one with A and B, one with A and C, and then one with B and C. So you'd need 3 scatter plots, and you'd have to examine it all for all of them together. And technically, you should look at it in a 3D world and all of that stuff that our puny brains cannot handle. But thankfully, we're starting out with an easier example than that. So now, like I said, we'll do this visual inspection. There's probably other ways to get to it, but probably the best way is by graphs legacy dialogues. So this is essentially, you want a certain type of graph, you can do it here. This is the old way. So I want a simple scatter. And now we're just going to put insta over and overall course there. I don't think we care about any of this. We don't care about this because we're just looking at for us. You should paste. I'm just gonna run. So here we can see, okay, yeah, this looks pretty linear, right? That was one thing that we were looking at. Now, we also want to look at, is there an equal distribution here, right? So one problem with this, and again, it's probably because I haven't taken out any outliers, see this it's kind of fanning. It goes from very pointed to wider. And that's saying that, you know, this multivariately, there is a skew. Where on this end, things are very particular, and over here, they're not. So you want to look at kind of the width, I guess, of this, and how far things are going from one side to the other. Again, it's not too terrible, but based on this, and the fact that that does not look like over here, I would say that it's non-normal. Once you take those outliers out, it might look different, and we'll see. Next up, we have the homogeneity of variance-covariance matrices, which is something that we can get. Analyze, regression, no. General linear models, univariate, no, multivariate. So that's an ANOVA, right? That's what general linear models is, which always confuses me. And we're just going to put this in like this. And then under options, we're going to ask for a couple things. So descriptives, we already have most of the descriptives, but it sometimes can be nice to have it all in one table. We want homogeneity tests, estimates of effect size, observed power, and the residual SCPP. gonna say the little matrix. Okay, and I'm not going to change model because, yeah, it's full factorial, which is what we want. We're not adding any contrasts or plots or any of that post hoc stuff because, again, we're just looking for this right now. We're not actually running it. So I will click OK. And this gets me the descriptives of what the mean and standard deviation is for everything. So this is just a bit simpler for looking at that. And now we want to look at the equality of covariance matrices. So boxes M. And then we also want to look at a test of sphericity. I'm not going to try to explain what these mean right now. You've probably learned about it in class, but as with all other tests that for assumptions, we don't want it to be significant. And these are, which means there's a problem, which might be those outliers, right? Again, I'm being lazy. I'm not taking the outliers out because this is just a demonstration for this video and you'll have to actually see it up later. Then we also have Levene's test. We don't really care about Levene's test as much right now because, well, it's multivariable. Multivariate. Once we get into multivariate, this univariate test doesn't matter as much as the multivariate versions. Yeah. The rest of it can be helpful, but we don't need right now. So I will leave you with this. What to be aware of when testing assumptions. There's blanks here. Try and fill them out, and we'll go over it in lab on Monday. And we'll also do this in lab on Monday, actually running the MANOVA. If you want to have extra fun, you can do it using SAS. But we don't have to yet. We will soon be using SAS though, so don't forget, keep it in mind, you know. Yeah, so for lab, on Monday, try and fill this out, all these blanks, and go through, actually remove these outliers, and see what that does for all of these assumptions. Write it down and be ready to talk about it on Monday. See you all then.